Does anyone have any questions? Does anyone have any questions on the evens from the ones we did yesterday? All right. So, yes. Okay. Number 10. Okay, what about number 10? Okay. So, what does the negative in the front cause to happen? It causes it to be a reflection where? Yep, reflect across the x-axis. Okay. Now, what does the 2 cause to happen?
I don't know. Is that the slope?
Yeah, but what does that do? Is it a stretch or a shrink or nothing?
It's a stretch.
It is a vertical stretch. Okay. So even though that negative is in the front, that negative isn't changing that it's a stretch because the negative makes it go down.
Wait, when you're plotting it, it comes like it'd be down to.
Yeah. Okay. But it doesn't make it not a stretch because the negative just makes it flip. And when we talked about it, we talked specifically about how we look at the absolute value of A because that's what's affecting the slope of the arms. Okay. But when we think about like our transformations, the negative flips it and then the 2 stretches it. It's like 2 separate things that's happening there. Okay. Then, what does the -3 cause to happen? Right 3. Okay, then what about the +5? Up 5. So what is our vertex?
It's 3.
You go right 3, up 5. And then what's our slope?
Oh, it's negative.
So we go down 2 over 1. That gives us half of our graph. And then we make it symmetric by doing the same thing to the other side. And so that is what number 10 should look like. Okay, any questions on the piecewise function section?
You go for number 6.
Number 6. Okay, for number 6, in the very front, what does that minus cause to happen? Yep, it is a reflection across the x-axis. Okay, then what does the -3 cause? Down 3. Okay. So what is our vertex? 0, -3. Okay, then our slope is, it has a negative, so that's understood to be -1, so it's down 1 over 1. So our graph should look like this. Okay, now do we have any questions on the piecewise section? Let's do 20, just to, I've had a couple questions about it today. So for number 20, okay, our first equation here is 3x minus 2 when x is less than 1. What is our y-intercept for 20? What is our slope? Up 3 over 1. Now, this says when x is less than or equal to 1. Would it make sense for me to put a bunch of points going this way?
Just as I did that.
Not really, right? Because since it is less than, it goes to the left. Okay? And at 1, is it going to be an open or closed circle?
Closed.
Closed. Okay, now we're good to look at the second equation. For the second equation, what is our y-intercept?
2.
What is our slope?
Oh, I'm doing it on the wrong way.
Now, we have specifically x is greater than 1. If it is greater than, that goes to the right. Okay, we erase any pieces we don't need. At 1, will this get an open or closed circle? So that is what our graph should look like for number 20. Okay, so real quick, okay, if we have x is less than whatever. So if we have less than, Okay? It goes left. Less than goes left. We can also see that because if we have it this way right there, that arrow points left. That helps us remember which way to go. If we have x is greater than, okay, we go right, which is why I'm emphasizing the grrr part of greater than, right? It has an R in it. It goes right, okay? If you look at this part, we can also see which way it goes just by looking at that arrow. Okay, it goes to the right. So if it's less than, it goes left. If it's greater than, it goes right. Okay. Now, 22 is just 3 horizontal lines. That is all this is. Okay. So the first one here, 2, where x is less than or equal to -3, is going to be a horizontal line at 2 when x is less than or equal to -3. Okay. Then our second piece is a horizontal line at -1 when x is between -3 and 3. So it is -1 between -3 and 3, an open circle on both ends. Okay, then we have our last piece, which is 3 when x is greater than or equal to 3. So it's going to be a horizontal line at 3 when x is greater than or equal to 3, which would look something like that. Okay, so remember, if you have just a constant in there, it is a horizontal line. Okay, so from here, we're going to pick up where we left off yesterday, which is question 23. Okay, and question 23 talks about the admission rates for an amusement park. Okay, so we have a word problem here. So our word problem tells us that children 5 years old and younger are free. It also tells us that children between 5 and 12, where 12 is included, are 10. We have that children between 12 and 18, where 18 is included, are 25. And adults are 35. So the first thing we have here is we are going to write out this function. We're going to do the function f of x is equal to, okay, so how much is free? 0. Okay, and that will be when the kids are between 0 and 5. And if I read this, this is children 5 years old and under. So that means our equal to is going to be on 5. Because do you think they're going to be bringing a 0-year-old to the amusement park? Probably not. Okay. Now, children between 5 and 12 are how much? 10. Okay, and that goes between 5 and 12. 12 is included, so it gets the or equal to. Okay. What about for children 12 and 18? How much is that? 25. And so we go 12 to 18. Which one's included for that one? Okay, then adults. How much are adults? And that is just going to be x is greater than 18. Okay, then it wants us to graph it. Okay, it's 18. Yeah, I just had it written wrong. Okay, then we're going to graph the function. So from 0 to 5, it is 0. Okay, at 0, is that an open or closed circle?
That's open.
Open. Okay, at 5, is it open or closed? Closed. Okay, then we switch to 10, so it will be 10 between 5 and 12. So at 5, is that open or closed? Open. And at 12, is that open or closed? So we should have open, closed. Okay, then for 12 to 18, it is going to be 25. Okay, at 12, is it going to be open or closed? And at 18, is it going to be open or closed? Okay, then adults are going to be at 35 for 18 and up. And will that 18 be open or closed? Open. Okay, and specifically, what type of piecewise function is that? It's a step function. It is a step function because it makes steps. Correct. All right, now we're going to look. Yes. Now we're going to look at number 24. Okay. We're not going to do all of it together, but we're going to talk about it. Okay, so we have a delivery service that charges according to the following piecewise rule based on the distance D in miles from the restaurant. We're going to ignore the fact that I royally misspelled restaurant. Okay.
Oh, restraint.
Yeah, we're going to ignore that. We're ignoring that. So we have C of D. I'm assuming that I just very much misspelled it, and then my computer auto-corrected it to restraint, because I, even in my old age of 28, cannot spell restaurant for the life of me. So, you know, we do our best. I Google it every time I spell it, and I just didn't Google it when I made that. So we have our function C of D, okay? So we have that it is 2.5 when it is between 0 and 3. We have that it is 0.8D plus 10 when it is between 3 and 12. And we have that it is 0.5D plus 3 when D is greater than 12. Okay, that is what we have. Okay. Which one of those three equations would you plug into to figure out the cost to deliver at 2.5 miles away? The first one. Okay. What would you do to find the cost to deliver for 10 miles? Which equation would you use? The second one, and you just plug it in. Okay. Now we're going to talk about C. So C is a different type of question. It says the what distances results in a delivery cost of exactly $8. Okay. So this over here is what represents our delivery cost. Is there any way the first equation is going to have an $8 delivery fee? No, because what is the delivery fee for the first equation? $2.50. It is just always $2.50. So we're going to set up two equations. We're going to do the second one. We're going to do 0.80 D plus 0.10 equals 8. And we're going to do 0.5 D plus 3 equals 8. And we're going to see which of those works. Okay, so if we start with, let's start with the second one. So for 0.5 D plus 3 equals 8, what do I need to do to solve this? Subtract 3. So we get 0.50 D equals 5. What do I do from there? Divide by 0.5. So we get D is equal to, it's 10. So, because if you divide by a half, you multiply by the reciprocal, so you end up saying 5 times 2. Which is 10. Okay, but anyways, D equals 10. Does that fit in the miles that it needs to be for that last section? No. So can it be 10 miles? No, it cannot be this one. It cannot be that. Okay, so now let's solve the one for the second equation. What do I need to do to solve that one? Subtract 0.10. So we have 0.80 D equals, what is 8 minus 0.10? 7.9. Divide by both sides by 0.8. Does anybody have a calculator handy and can tell me what that is?
She could.
A question like that would be on the calculator. Half what? Is that what you got, Jaden?
No, like 7.1. I don't know. I'm not even. Yeah,
I stopped blindly trusting people after I got a wood question wrong one day. Or let's just do 8 minus 0.1, 7.9 divided by 0.8. Yeah, it is 9.875. Okay, so what distance results in a delivery cost of exactly $8? 9.875. That's all it wants us to do. What you mean?
Because it has to be $8. I thought.
Wait, no. The delivery cost has to be $8. But so to get to a delivery cost of $8, it has to be 9.875 miles. Yeah, that's the miles. So it would be 9.875 miles. Okay. Now, we're going to look at number 25. So 25 is the city's parking garage charges C of X. So it charges $0 between 0 and 1 hours, $4 between 1 and 3 hours, $8 between 3 and 5, and $12 between or after 5 hours. Okay, so how much does someone pay if they're parking for 2.6 hours? What was that? $4. How much does someone pay for exactly 5 hours? $8. How much for 7 hours? $12.
Oh, I'm sorry. I looked at the wrong one.
There we go.
Give me
Okay, now we're going to look at 26. Or actually, we're not going to look at 26 because these are our step function problems, okay? So we're going to do our odds still, okay? So for number 27, is this a ceiling or a floor function?
That's a ceiling.
That is a ceiling function.
So it's 3.
Okay, so we have to find the ceiling of 2.45. What is the ceiling of 2.45? 3. Okay, now what does this? Is that a ceiling or a floor? A floor. So we're trying to find the floor of negative 19.9. What would the floor of negative 19.9 be? Negative 20.
Oh, 20. Oops.
Okay, so let's talk about it. Okay, so the floor function means it rounds down to the nearest integer, right?
Yeah, that makes sense.
So for negative 19.9, we have negative 20, negative 19, and negative 19.9 is somewhere in the middle, right? If we round down, so we round to the nearest number below it, that would be negative 20. That is why it rounds down there, because it's going to the nearest integer below. Okay? Now, if we look at 31, is 31 asking about the ceiling or the floor function? Ceiling. Okay, so it's asking us to do the ceiling of negative 4.2. What would be the ceiling of negative 4.2? Negative 4, because it has to round up to the nearest integer. So we have negative 5 and negative 4, and negative 4.2 is in the middle of them, right? So if we're rounding up to the ceiling, that means we're going to round to negative 4. Okay? If you are ever unsure of what number it needs to go to, do the numbers immediately on both sides of it and go, does it go up or does it go down? So just for funsies, we'll look at a couple of these over here. Okay? Is 26 a ceiling or floor function? Floor. So we have to take negative 7.8 and take it to the number below it. What would that be? Negative 8. Here we have the ceiling or floor function. Ceiling. We have 18.1, so it needs to go to 19. Here for 30, do we have the ceiling or floor function? What's the floor of 3.75? 3. Because it goes to the number immediately below it. Okay. Now, for 32, we're going to talk about how to set this up. Okay. Yes, ma'am.
Wouldn't 26 be negative 7 because you go down and negative 7 plus
So the number is negative, you have -8 and you have -7. -7.8 is between those. So when it's floor, you go down. So -8 is the number below it. It just feels weird because it's opposite of your, like, if it's 7.8, you do go down to 7. But since it's negative, it has to go more negative. But that is the trick. If you are not sure on any of those, put the numbers on both sides of this number and then go, do I go up or down? And that'll tell you your answer. Okay, so now we're going to look at 32. Okay, for 32, we have the table that shows the cost of renting a sound system for a concert. Isabella rents a sound system at 1 p.m. and she plans to return it before 4. So we're going to write our function. So f of x is equal to, all you have to do to write the function is take the things over here and put them in the table, right? So we would do 24 between 0 and 1. It would be 48 between 1 and 2. It would be 60 between 2 and 3. And 72 between 3 and 4. For B, it says Isabella will pay blank dollars if she returns the system between 2 and 3. How much will she pay? 60. Okay, then it says if she's 30 minutes late, so if she turns it in 30 minutes after 3 p.m., how much will she pay? Or she'll pay an additional what? $12, because 72 is $12 more than 60. I wanted to do that one together just because the way it's worded is weird. It's just meaning 30 more minutes than this. It bumps her to the next. Yeah. All right, now 33. Okay, for 33. Okay, before I do this one, I'm going to go ahead and talk about part C of this. It says which one represents a ceiling function and a floor function. So it says a base charge for $25 a month. Okay, then we have $6 for each full hour of personal training rounding up. If it's rounding up, would that be a ceiling or a floor? That would be a ceiling. Then it has plus $4 for each hour of going to the sauna rounding down. So that would make that a floor. Okay, so a client trained for 3.8 hours and visited the sauna for 4.1 hours. What is their total cost? So it doesn't mention how long they're at, how much time. So we're just going to assume it's 1 month that they do this over. So how much is it for 1 month at the gym? $25 plus. Now, the client trained for 3.8 hours. Okay, so what is the ceiling of 3.8? 4, so that is 4 hours. But how much is it per hour? It's in the question. 6. Okay, plus she then visited the sauna for 4.1 hours. For the sauna, we had to do the floor function. So what is the floor of 4.1? And how much money is it per hour for the sauna? Okay, so to find the answer to this, we just we multiply these. So what is 4 times 6? What is 4 times 4? So what is 25 plus 24 plus 16? $65. Okay, because 24 plus 16 gives you 50, or 40 plus 25 is 65. Okay, now we're going to do the same thing but for B. Okay, so for B, a client went to the gym for 3 months. So what do I need to do for that? 25 times 3. Okay, plus they trained for 11.25 hours. So training is a ceiling or floor? Ceiling. So what's the ceiling of 11.25? Yep, it's 12. For how much money?
$6.
Okay, plus she went to the sauna for 6.4 hours. What's the floor of 6.4? 6. So it'll be 6 times how much money is it for that? So we have 3 times 25, which is, what is 3/4? Then we have 12 times 6, which is 7. Is it 70?
No, only.
Making me doubt myself. Yeah, it's 72. Then what is 6 times 4? 24. So if we add those 3 things together, we get what? 171. So it was $171 that month, or for those 3 months. Okay, so from here, okay, we're done with our review. Okay, so for the rest of class, I want y'all to work on y'all's review. Remember, this will be due at the beginning of class tomorrow, because our test is tomorrow and on Thursday. Tomorrow will be no calculator part. Then on Thursday, you'll be able to use a calculator. Both parts can be done without a calculator. It's just the parts on the calculator part have bigger numbers to plug in, things like that. Things will be easier with a calculator. But, yeah, we have 2 parts. You will need your yellow papers also to turn in. So make sure your review and your yellow paper assignment are all ready to turn in tomorrow. Any questions?
Oh, will you be a tutor or is it another teacher?
Both today and tomorrow is different teachers. Okay, but there are tutors in there every day for each subject, so you're good.